Hey guys, my name is Matthew D'Antuono, and this is my project number 1. The paper I chose was called the Voting Analytic Hierarchy Process Method for Selecting Supplier. And this problem was based on the Malaysia furniture industry and trying to figure out which supplier to choose from. So from a list, in this case, from a list of 10 suppliers, we were trying to choose one based on 8 selection criteria that branched down into 13 sub-criteria. The methodology I used was called the Analytic Hierarchy Process, or AHP for short. And a little bit more specifically, the Voting Analytic Hierarchy Process, or VAHP. Now, if you know what AHP is, VAHP is very similar, except rather than knowing the relationship of importance between different criteria, votes are cast by a number of candidates in order to figure out which one they think is the most important. And these candidates can be managers, employees, anything like that. Anyone who has a say in the company. From there, from all these votes, you use a linear programming model to figure out what the weights are for each criteria. The method used is a 6-step AHP method with selecting supplier criteria, structuring the hierarchy of the criteria, prioritizing the order of criteria or subcriteria, calculating the weights of the criteria or subcriteria, measuring supplier performance, and identifying supplier priority. As you can see, step 3 and 4 are underlined. That just indicates that for the VAHP process, these two are a little bit different. In order to prioritize the criteria and calculate the weights, we have to take the votes and put them into that linear programming model to figure those out. From an implementation, I use both Microsoft Access in order to update your number or type of votes during the survey, so you could do this problem again with a different number of criteria or a different number of votes or anything like that. And then from there, I exported to Excel in order to complete my calculations. So right now, I'm going to go ahead and show you guys what my database looks like. So I have 3 tables: my criteria vote, my sub-criteria vote, and my relationship tables. So my criteria vote table, you can see I have my criteria ID from 1 to 8, since these are the main criteria, ranging from quality down to facility. Across the top, I have columns labeled first, second, third, etc. And what that means is that is what type of vote. That's the type of vote. And then the number underneath of it is how many of that type of vote it got out of 60 candidates. So for example, quality got 15 first place votes and 9 fourth place votes. In order to form the sub-criteria vote table, the same thing was done. However, as you can see from the criteria ID, which links back to the criteria vote table, normally only 2 of them shared a criteria ID. This means that these 2 branched off quality. So these 2 were compared against each other, and although the votes didn't tally up to 60, which the paper never explained why, this is how many first place votes, 25, that Factory Audit got. And Factory Audit got 17 second place votes. The third place column is simply for our last one down here, which has 3 categories branching off the main criteria. And going over the relationship table, you can see that the criteria ID is linked to the criteria ID column in the sub-criteria vote table. So, in order to go from Access to Excel, you go up here to External Data, and you click Export to Excel Spreadsheet. So after you've updated whatever numbers you'd like to update inside of the database, you can send it to Excel in order to complete your further calculations. So here's what it looks like after you send it to Excel. Do a little bit of formatting, color some things up to make it a little bit easier to understand. However, you can see that the gist of it is the same. You have your 8 criteria here, your 13 sub-criteria here, and all the votes associated with them to the right of that. From here, you use this linear programming model down here, which takes a little while to understand. Maybe not as much for you guys, but it took me a little while to understand. And after I took some time to look at it and figure out what each of the variables meant, right here, I was able to use Excel Solver. So you go up here to the Data tab, and you can use Solver then you can input your linear programming model, your objective, the variables you're using, and the constraints. So as you can see here, I changed all of my x's for my criteria to 1 in order that I could run this again and show you guys. So I'm trying to find my weight right here of quality. Based on these constraints, which are presented in the linear programming model that we saw a minute ago, and changing the variable x's right here in order to find a solution. So we just click solve, and our solver says the solver found a solution. All constraints and optimality conditions are satisfied. So click OK. You can see right here that we have, after we calculate our weights, we take the total of them and make them out of 100%, and this is what we get right here. Same exact process happens right here for the sub-criteria table, and you can see here our normalized data results. Now, unfortunately, I was unable to get the exact results that were presented in the paper. However, I did find a couple of data mishandlings in the paper where they switched values up and labeled them in the wrong place. But in order to finish the problem, I went ahead and inputted their weights into this table in order that I could finish the problem and finish explaining this to you guys. So here you have their criteria and their sub-criteria, the weights that they got based on the linear programming model, and then their normalized weights. So you can see here that 13%, 13%, 12%, all the way down to 11. So all of their weights were a lot more evenly distributed than I found on mine. One of mine was 24 and one of them was 3 or something. And the same thing for the sub-criteria table. So from here, in order to get the overall weights for factory audit, you would multiply, since factory audit is a subset of quality, you would multiply the quality weight, 13%, by the factory audit weight, 43%, which gives you an overall of this, 0.05 or 6% if you round up. So after you do that for each one, you have the total weight for each one of these criteria, and then you also do something called a score, which is again where people vote and they take, for example, in this problem, this is the rating of just supplier 1. They would rate supplier 1 on how well they think they do on quality. They gave them a 7. How well they think they do with their business skill. They gave them a 9. From here, what you do is you multiply these scores by the weight, which gives you your subtotal. After you've done this for every criteria and every score, you find yourself with a total scores number down here. In this case, it's 6.02. This score, after you've done this for every supplier, 1 through 10, is what you use to determine which supplier you should use. Unfortunately, in the paper presented, they stopped after 1 supplier and did not give me all the information to finish going. So like I said before, my results were a little bit different. I found about 24 and 19% when they found 13 and 13. There's a lot more even. Same thing with the sub-criteria. Mine was a lot different than theirs, especially in the second one. I got 8%, they got 56. So the paper was definitely well written, had a lot of information. However, it was a little bit hard to understand the process they used, since they just said the process they used and then gave the answers. They didn't really write out the problem how they did exactly what they did. That makes it a lot harder to understand. Also, I realized that this paper was simply an implementation of another paper's work. That paper was called The Appropriate Total Ranking Method Using DEA for Multiple Categorized Purposes by Noguchi and others in 2002. So I ended up having to use that paper to understand the process a little bit better. For future research, I could go through my work again, try and figure out where my error is in my calculations or in my linear programming model, and also continue to try and apply this to real-world industry problems to see if I can solve a full problem. And along with that, just simply solving a full problem, since this paper included only an example of 1 supplier at the end rather than all 10 to figure out which one was better. Thank you.